Okay, this is a 2015 question 6, so it's an investigative task, and it's focused on the normal distribution and the distribution of means and what variability may be associated, and it's just basically a pretty good problem for understanding. And truthfully, it's not one of the more challenging investigative tasks. So here we go. Corn tortillas are made at a large facility that produces 100,000 tortillas per day on each of its 2 production lines. The distributions of the diameters of the tortillas produced on the production line A, so production line A, is normal with a mean of 5.9. So they're telling us this mean right here is 5.9. And the distribution of the diameters of the tortillas produced on production line B is approximately normal with a mean of 6.1. The figure below shows the distribution of diameters for the 2 production lines. Okay, so we see that we have a bimodal distribution that is made of 2 normals. So we have a normal for A and a normal for B. This is centered at 5.9 and this is 6.1. The tortillas produced at the factory are advertised as having a diameter of 6 inches. So the actual claimed mean is 6.0 inches. So this would be the mean of A and B. And that actually sort of makes sense because it looks like it's exactly in the middle between the 2 production lines. For the purpose of quality control, a sample of 200 tortillas is selected and the diameters are measured from the sample of 200. The manager of the facility wants to estimate the mean diameter in inches of the 200,000 tortillas produced on a given day. 2 sampling methods have been proposed. So we're going to basically take 200 tortilla sample and see what we have. So method 1. Take a sample of 200 tortillas from the 200,000 produced on a given day, measures of the diameter of each of the selected tortillas. So in this case, we would be looking at just saying, hey, you know what, we're randomly going to select 200 tortillas from the 200,000. So we'd be getting from both A and B. All right. And if we're getting from both A and B, we would expect our mean for this one to be probably about 6 inches because we're going to have half that 5.9 and half at 6.1. So on average, they'd probably average out to about 6.0. On method 2, randomly select one of the 2 production lines. So we're going to randomly select either A or B. We don't know which one we'll get. Maybe we flipped a coin to do that. Take a random sample of 200,000 of 200. So we're either going to have 200 from A or 200 from B, and take a random sample of 200 and measure the diameter of each selected tortilla. So in this particular case, we're either going to have a mean of 5.9 or we'd have a mean of 6.1. Depends on whether we got A or B. If we got A, we'd have 5.9. If we got B, we'd have 6.1. I didn't ask that yet, but that's what would have happened. So will a sample obtained using method 2 be representative of the population of tortillas made that day with respect to the diameters of the tortillas? Explain why or not. Why not? Well, method 2 said we're going to randomly choose 1. Well, if we randomly choose 1, if we choose B, it's going to be centered at 6.1, and it's not going to include a lot of A. And basically, if we randomly choose B, we're going to end up with a normal distribution, or our sample should look pretty normal, centered at 6.1. If we randomly choose A, we're going to get a normal distribution centered at 5.9. However, our real population is bimodal. And so, no, the answer is we would not using method 2. So a sample obtained using method 2 will not be representative of the population of tortillas made that day. The population of tortilla diameter center is at 6 inches and it ranges from 5.7 to 6.3. The shape is bimodal with peaks, and we always need to tell where our peaks are at 5.9 and 6.1. If method 2 were used, the resulting sample would be mound shaped with a centered at 5.9 and ranging from 5.7 to 6.1, or it would be mound shaped with a center at 6.1 and ranging from 5.9 to 6.3. Method 2 would only represent one of the production lines and not both. So the problem with method 2 is we'll either get B or we'll get A, but we won't get both. All right. So that takes care of that part. And I'm going to pause this for just a moment. Okay, so now we're looking at part B. So the figure below is a histogram of 200 diameters obtained by using one of the two sampling methods. All right, our two sampling methods was method 1 was take a sample of 200 tortillas from all of them. And method 2 was either randomly selecting A or B and selecting 200 tortillas from either A or B. Considering the shape of the histogram, explain which method 1 or method 2 was most likely used to obtain such a sample. So they're talking about shape. Well, sometimes it helps to kind of put a curve to this. So if I put a curve to this, it's like, hey, I got a bimodal shape. And if I had to draw a line, I'd say, you know what, it looks like it's centered about 6. Well, we said earlier that method 1 would take the entire population and would be centered at 6. We also said method 2 would not provide a bimodal. So this had to be method 1. So method 1 was used to create this histogram. And this can be concluded because the histogram shows the bimodal characteristic of the population and is centered at a diameter of 6 inches and has a range similar to that of the population. And why do I say that? Well, the population should have been from about 5.7 to 6.3. Method 1 represents both production lines of the production. Method 2 would only represented one of the production lines. You did not have to include that, but good piece of information. Which of the two sampling methods, method 1 or 2, will result in less variability in the diameters of the tortillas on a given day? Explain. Well, method 1 would have variability from as high as from a low of 5.7 to about 6.3. Method 2 would be one of these two, either 5.9 to 6.3 or 5.7 to 6.1. So the range for method 1 would be 6. The range for method 2 would be about 4. So method 1, which includes the entire population, would have greater variability. So let's see what was said here. For a single day, method 2 would result in less variability. Method 2 represents only one production line, while method 1 represents both production lines. Method 1 will result in a sample of approximately 6.3 minus 5.7, which equals 0.6. So we'd expect it to have a range of about 0.6. All right. The ranges of both production lines are 0.4. So method 2 would only have a range of 0.4 because it was only representing one of the production lines. Both. All right, so very important to explain and make sure you're being specific. So each day, the distribution of 200,000 tortillas made that day has a mean diameter of 6 with a standard deviation of 0.1. So what they're saying is our mean is here and a standard deviation of A and B together equals 0.11. All right. For samples of size 200 taken from one day's production, describe the sampling distribution of the sample mean. Oh, the sampling distribution of the sample mean diameter. All right, so they asked for the sample mean, so we need to know central limit theorem applies. Well, we actually have a bimodal distribution, so that's kind of an issue. We have a bimodal distribution, so it's the underlying distribution is bimodal. It's not normal. However, the sample is size 200, so n is greater than or equal to 30. So the distribution of the sampling means are normal by central limit theorem. So the distribution of sample mean diameters for sampling method 1 will be, and this is a very key word, make sure that whenever you're describing this, that you use this, is approximately normal. They will count off if you say the normal. It's not, it's approximately normal because the sample size 200 is greater than 30. So the mean will be the mean. That's always really nice. So the mean will be the mean. So the mean is 6 inches. With the standard deviation of X bar is the standard deviation of the population divided by the square root of n. So 0.11 divided by the square root of 200. And so we end up getting 0.0078 inches. Please remember the standard deviation of the sample means is always the standard deviation of the population divided by the square root of n. We'll pause right here for just a moment. So part E says, suppose that one of the two sampling methods will be selected and used every day for 1 year, 365 days. The sample mean of the 200 diameters will be reported each day. Which of the two methods will result in less variability in the distribution of 365 sample means? So let's look back. So method 1, we're going to take a random sample of 200 from, and we will end up getting a mean of about 6.0. Whereas with method 2, we're either going to get A or B. So some days we'll get A with a mean of 5.9, and sometimes we'll get B with a mean of 6.1. So essentially, this one will end up with 2 peaks. This will end up with 1 peak. So this is ultimately going to have less variability because we're looking at only one distribution as opposed to 2 separate distributions. So sampling method 1 will have less variability because it'll have a mean of approximately 6 inches for every one of the 365 days, while sampling method 2 will result in having approximately half of the days having a mean of close to 5.9 and the other having a mean close to 6.1. Method 1 results in a single peak, whereas method 2 has 2 peaks, indicating greater variation from method 2. Basically, method 2 having 2 centers makes it more variable. A government inspector will visit the facility on June 22nd to observe the sampling and to determine if the factory is in compliance with their advertised mean diameter of 6 inches. The manager knows that with both sampling methods, the sample mean is an unbiased estimator. When it says unbiased estimator, that means the mean of the sample will equal the mean of the population. So they know that when they take a sample, it's going to match whatever the population means. However, the manager is unsure which method is more likely to produce a sample mean that is closer to 6 inches on the day of sampling. Based on your previous answers, which of the 2 sampling methods, method 1 or 2, is more likely to produce a sample mean close to 6 inches? Well, first off, part E, we kind of answered that. We said that method 1 will give us a mean of 6 inches, where method 2 is either going to give us one at 5.9 or close to 6.1. So if we want close to 6, we're going to choose sampling method 1. So the manager should choose method 1 because it will have a mean of approximately 6 inches. It's expected that sampling method 2 will result in about a mean of 5.9 or 6.1, depending on which production line were selected. In either case, the mean is not the desired 6 inches. All right, so they should choose number 1. Thank you.